Assalamu alaikum. This question on fluids. A 5 kilogram rock of density 4,800 is suspended by a string such that half of the rock's volume is underwater. Find the tension in the string. So we have here a situation of a water, and we have a rock, but half of the volume of the rock is underwater. So this is V over 2, and the other half is above water. And we need to find and this rock is attached or hanging by a string. So basically, we have here few forces affecting this rock, or the rock is experiencing some forces. We have the tension force. As well, we have the buoyant force on the rock from the liquid or the water, and we have also the weight of the rock. So in order to find the force of tension in the string attached to the rock, we can utilize the Newton's second law, sigma F equals ma. And because this is an equilibrium, so it equals 0, so the force will be the forces. We have two forces, positive forces up, pointing up, which is the tension plus the buoyant force minus the weight of the rock should equal to 0. So the tension force should equal weight of the rock minus the buoyant force. Now the weight of the rock is mg, so it is mass of the rock by g, minus the buoyant force is not all the rock is immersed underwater, just half of it. So it is the volume. It is the volume displaced, the displaced amount of water displaced by the rock. So it is rho, density of the water, by the volume equivalent to the displaced, which is V divided by 2, not the whole volume, multiplied by G. So we know the density of water, we know the mass, we know G, we know all these but the volume. So in order to find the volume, we know that the density equal mass divided by volume. So volume equal the mass divided by density, and the mass is 5 kilogram divided by 4,800. So the volume will be 0.001 meter cube. So we can now substitute mass of the rock is 5 kilograms by 9.8 minus density of water 10 to the power 3 or 1,000 kilogram per meter cube, and V over 2, the whole volume is 0.001 divided by 2 multiplied by G, and this math or calculation will yield a force of tension of 44 Newton. Thank you.